All right, we are going to talk about section 8.3, geometry formulas. The geometry sections are split into two parts. This first one is an introduction to the formulas, and then in our next class, we'll do section 8.4, where we use these geometry formulas for some more extended problem solving. So we're on page 61 in the packet, and on this page, it tries to give an overview of the way we can sort of group and think about geometry formulas. When you're looking at a situation with geometry, it's one way to sort of center yourself and figure out what you're looking at is to think about whether we're talking about perimeter, area, or volume. And each of these has different similarities. So if you're looking at perimeter, you're looking at the length around the outside of a two-dimensional shape. This is a one-dimensional measurement. You are just measuring the outside. And so these are going to be linear units with no exponents, for instance, inches, meters, centimeters, or yards. To find the perimeter of almost every figure, we don't need a formula. We add up the lengths of all the sides. The only time we can't do that is with a circle, because a circle doesn't have sides. It's a curved shape. And so we need to have a formula. The interesting thing that we've talked about before that kind of disrupted mathematical thought for a while is that the formula that we use for the perimeter of a circle brings in this strange value pi. The length around a circle is always going to be found by multiplying pi times the diameter. Pi is a value that is equal to about 3. Now, that's a pretty, we can get, usually when we see that approximation, we get a little bit more detail, 3.14. But just for the sake of conceptualizing it, thinking of it as 3, not when you're doing the calculations, but just when you're thinking about what it means, I think is kind of useful. So if I draw the diameter across the center of the circle, if I took this length right here and I started bending it around the side of the circle, choose a different color there. So one of those diameters would go to about here. The second diameter would go to about here. And the third diameter would reach almost completely around, and there'd be a little gap here. So 3 diameters are needed to go around the circle. Now, unfortunately, it's not exactly 3. It's a little more than 3. How much more? About 3.14. Not exactly 3.14. This is a irrational number, which means that its digits go on forever and never stop. The ratio is a complicated number. But that's where pi came from, is the fact that no matter how big or small the circle is, it's going to take a little bit more than 3 diameters to go around the circle. And so that's our formula. So circumference is equal to pi times the diameter. Every other perimeter, we have some figure, whatever that figure is, and we can add up the lengths of those straight sides around the figure. So, area is a two-dimensional shape. And it's the flat surface enclosed by a shape. It's always going to be 2 dimensionals, and therefore for any unit for area, we have to have square units. Really important to remember when you answer the question to put in that exponent. All area formulas are based on the area of a rectangle. So when we're thinking about a rectangle, let's say this is a rectangle that's 3 units by 5 units. I'm going to just split that up. That means it's going to have 5 rows of 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And each of those units is a little square. So we have 15 squares to cover that rectangle. So that's the formula for the area of a rectangle, the length times the width. And if we are looking for the area of a circle, it's going to be based on the radius. If I take this radius and I make it into a square, I need approximately 3 squares to cover or wallpaper the circle. So this is r squared, this is r squared, and this is r squared. And if I take off these little outside areas and cut them up and move them over here, it turns out that they almost perfectly fill in that extra spot with just a little blank spot. So it isn't exactly 3 r squareds, it's 3.14 r squareds. Pi times the radius times the radius. If I'm looking at the area of a triangle, and sorry, this is printed a little bit weird, 1/2 base times height. Any triangle that I draw, if I take a second triangle that's exactly the same shape, and then I cut off this portion here and bring it over to the other side, it will make a shape that is a rectangle. And that rectangle dimensions will be the base of the triangle and the height of the triangle. So if I do the base times the height, I get the entire rectangle, but I'm only trying to find the area of the triangle, which is half of that rectangle. So what this formula is saying is 1/2 of the rectangle that's made with 2 triangles. Now, we don't have to memorize these formulas, but it is just kind of interesting to think about where they come from. And then the last one is volume. Volume is the amount of space that is occupied by an object. And that's a 3-dimensional space. And so when we're doing volume, we need to remember to include our cubic units. We're going to be figuring out how many of some amount of cubes will fill up a space. All volume formulas are based on area with an additional dimension of height. So volume is always going to be equal to the base of the object times the height. So for instance, if we're looking at a rectangular solid, we have some base of the object that is a rectangle, length times width, and then we're going to add some height to that situation. And we will, so we've got our length times our width, and then we add this 3rd dimension height, and we have a 3-dimensional space that it's kind of like we're layering things on top of each other. Same thing with the volume of a circular cylinder. We find the area of the base, and then we're thinking about stacking up a bunch of these circles and seeing what the entire volume is. So if I've got one circle here, that's 1 unit in height, and then I have another one here, and then I have another one here, and another one here. And this is not a particularly perfect diagram. Maybe there's one in here. So each one of these is 1 unit in height. That would mean that my height was 5. So I'm going to take the area of the base and multiply it by 5, and I will have the volume. And you'll notice that there'll be 3 dimensions: length, width, and height. Or in the case of the circular cylinder, the radius, the other radius, and the height. Sorry, I meant to put a 3 here. And there's always going to be 3 dimensions in every volume formula, so that we can be filling that space. So in your packet, you will see in the front of the packet, there is a sheet with all the formulas that you will need to refer to, and you do not have to have those memorized. You're going to figure out how to use those. I also included here at the end a formula sheet I like that just has a little bit more detail about each of those formulas, and so you're welcome to look at that as well. Though it's got like it's a little bit more confusing, or maybe more interesting. I don't know. The one in the packet is more straightforward. It just has the formulas, but if you wanted a more detailed version, that's at the end of this section. So this section is designed to give you a chance to experiment with these formulas. I mean, normally we would do it all in groups. I'll do the first 2 just to model how it's done, and then I'm hoping that you will see what you can do with the rest of them and go back and look at the answer key. And it has an important note at the top of page 62. You may use a calculator for any problems in this section. Calculators will be allowed for problems on the quiz and the final. If a diagram is not provided, please draw and label a diagram to help use the formulas correctly. That's kind of the way to show your process carefully and make sure you're going to get the right answer or get partial credit if you don't. And express your answer in complete sentence with units, because they've asked us a question. We need to answer it in a sentence with units. So letter A says, Pizzicato sells a 16-inch diameter pizza for $19. What is the circumference of the pizza? What is the area of the pizza? So it doesn't include a diagram, so I'm going to draw myself a little picture of this pizza. And the measurement that I'm given is the diameter. Drawing the diagram allows me to just sort of process that information. Diameter is the thing that goes fully across. In a circle, the diameter is the one that goes all the way across, and the radius is just halfway. Okay, so there's my 16-inch pizza. And I need to find the circumference. If I look on my formula sheet, circumference is equal to pi times the diameter. And so in this case, I'm going to do pi times 16. That's approximately 50.27 inches. I can either do 3.14 times 16 or use the pi key on my calculator. If I use the pi key on my calculator, I will often get just 16 pi back out. Depends on your calculator, but on the common symbol on many of the scientific calculators is there's a button like this that's going to transfer back and forth. It's towards the bottom of your calculator from the exact answer to approximate answer. On other calculators, there's other ways to do that, and please let me know if you're having trouble finding that. We can also do 3.14 times 16, and then we won't get that pi. And this was 16 inches. If I include that in my actual calculations, then I will remember to include it in my final answer. For area, that's equal to pi r squared. Well, the diameter is 16. So that means the radius is 16 divided by 2, or 8 inches. So I'm going to do pi times 8 inches times 8 inches, which will give me 64 pi, and my inches are squared. That's good, because I know that for area I need to have square inches. If I approximate that, I should get 201 inches squared. So I can write out that the pizza's circumference is 50.27 inches. And the area is 201 inches squared. And in order to get full credit, we do need to include not just the units, but the correct units in terms of area or perimeter. All right, letter B says a yield traffic sign is an equilateral triangle. Equilateral means that all three sides are the same. It has a base of 48 inches, and it has a height of 34 inches. What is the area of the face of the sign? So I'm looking for the area of a triangle. If I look back on my formula sheet, I'll see that's 1/2 base times height. And then I can fill in those values, 48 inches and 34 inches. And I like to include the units in the actual calculating so I can see that not only am I going to get the correct number, but I have inches times inches. So I have inches squared, which is good because I'm finding area. So I'm looking for something dimensional, just a way to double check that I am using the right formula. And if I do 1/2 times 48 times 34, I get 816. So the area of a yield sign is 816. And it's always an option to, instead of, if you want in your sentence, if you don't want to use the exponent, to write out square inches. Some people like to do that just because it maybe makes more sense, or just both are fine. All right, so please try the rest of these group work problems, and the answer key is available for you to look at and make sure you are doing those correctly. Remember to draw a diagram if the diagram is not provided, and I recommend doing that for web work as well, and then label that diagram. That's a way for you to just make sure you're understanding the information, and then you need to find the correct formula, record that formula, fill in the values, and then answer with a complete sentence with units. And there's kind of a fun problem on the second page, which I hope you will try, and then go back and look at the answer key and see how it went.